Welcome to Coach Taylor's class notes, and today we're going to talk about graphing linear transformations. So just like we kind of have all unit, let's review the things that we know. And one of the things that we know is we know that slope-intercept form is y equals mx plus b. The rate of change I know is also the letter m, which means my rate of change is the same thing as slope, and it's the same thing as rise over run. This should say what is b, and in my equation b is my y-intercept. So this is just a real quick reminder that will help us remember some of the things that we're going to need to know for this lesson here. So when we talk about transformations, we're talking about changing the line and changing where lines are, where they go, and all kinds of different changes that we can do with lines. So what we always need to know about transformations is we have what is known as a parent function. Our parent function is f of x equals x. And if we remember from Unit 2 when we talked about functions and our function notation, f of x is simply the same thing as y, so our line is y equals x. And if we change it to y equals x, we know that's in slope-intercept form. If we know it's in slope-intercept form, we know what our slope is, we know what our y-intercept is. So if I just have the number or the letter x, I know I have an invisible 1 in front of it. The number in front of x is my slope, so my slope is 1 over 1. My b, since there is nothing after x, my b is nothing, so my b is 0. So if I were to graph my parent function on the graph, its y-intercept would be 0. I would go up 1 to the right 1, and then we would simply follow that pattern all the way. So this right here is what our parent function looks like, or f of x equals x. And if we use our Desmos calculator, we can type in f parentheses x parentheses equals x, and we'll see that their line looks exactly like our line. And so anytime we talk about transformations, we're always going to be comparing these transformations to the parent function. And so I'm going to keep going back to that Desmos. So what we need to know about transformations is that there's two types of changes that we can make in the parent function. We can make changes to our b, which is our y-intercept. If our line shifts up, it means that it's positive. It's a positive b. If our line shifts down, we know it's a negative b. So if they were to write the equation f of x equals x plus 2, I would know that my line shifts up 2 because my y-intercept is now 2. If they had the equation f of x equals x minus 3, I would know that it shifted down because negative 3 would be my y-intercept. And so it's just a way for us to denote these changes from the original parent function. So the other thing that we have is we have changes in m. So m equals slope, it equals rise over run, and it equals rate of change. So we've got a couple of things that we need to note about changes in m. So if it's a negative m, that's going to equal reflected. So like if we held a mirror up against the line, it would be reflected as if it was in a mirror. If our m is greater than 1, our line is going to get steeper. If our m is less than 1, it's going to get flatter. And so one way that we can denote this and we can look at this is if I have a negative, or if I have, f of x, why do you hate me, pen? F of x equals a negative x. That negative tells me that's going to be reflected. I could have f of x equals 3x. That 3 tells me it's going to get much, much steeper. Or if I have f of x equals 1/3 x, I know that it's going to get much flatter. And so let's look at a couple of examples here. So what I always want to do is I want to graph my parent function. And my parent function is f of x equals x. And so I'm going to go from one corner of the graph to the other. I'm going to draw my arrows to show that my line goes on forever. So if we're looking at this, g of x equals f of x plus 3. So if we remember from our function notation, we remember that f of x equals x means that we can replace f of x with the variable x. So I can turn this into g of x equals x plus 3. So if this is y equals mx plus b, I know that my b equals 3. And I would know that my slope would still equal 1. So all I would do with this line is I would go and move my y-intercept to 3, and then I would graph it the exact same way with the exact same slope. So they would be the same level of steepness. They would just, my g of x would be shifted up 3. And so I'm going to show you on Desmos. So we have our f of x graphed, which is our parent function. And I'm going to come down here in my next one, and I'm going to type g parentheses x parentheses. I'm going to try and make this a little bit bigger. So g of x equals f parentheses x plus 3. And so if I compare the red and the blue lines, the only difference is that one's y-intercept is at 0, 3, the other's y-intercept is at 0, so I know that my lines have shifted up 3. All right, and let's look at one more example just to make sure that we understand what's going on. So again, our parent function is f of x equals x. So I can replace f of x with x, and by rewriting it, I can just simply make it simple. So g of x equals 1/2 x. So if I'm looking at this in mx plus b, y equals mx plus b form, I know that my m equals 1/2, and since there's nothing after x, I know that my b equals 0. So I'm going to graph my parent function first, because we always compare our transformations to our parent function. So there's my parent function right there. And now I need to type my g of x function. So they still have the same y-intercept, except this time I'm going to go up 1 to the right 2, up 1 to the right 2, 1 to the right 2. So when I graph this line, what I notice is that it is much less steeper. And when we talk about less steep, we talk about it would be easier, it would be an easier hill to climb. So g of x is less steep, meaning that if it was a hill, it would be much easier to climb. If it was more steep, if it was a hill, it would be much harder to climb. So let's look at our Desmos calculator real quick. So if I changed it, so f of x equals x is my parent function. G of x equals 1/2 f of x. And so if we notice and if we pay attention to these two, my blue line, just like the graph I graphed, is much less steeper than the red line. And so that is a quick introduction to transformations.